Welcome to Solving Time Value Money Problems with the BA2 Plus Financial Calculator. This is the fourth and final video in a four-part series designed to help you get the most out of this powerful little device. In this video, I'm going to show you how to solve any bond problem, or almost any bond problem, with the Bond Worksheet. The Bond Worksheet is very different from the worksheets that we've had up until this point. For example, this worksheet has a built-in calendar which allows us to take a bond's original settlement date, that's the date the bond was first sold, and take it up to its exact redemption date and work out the yield and present value between those 2 points. Or we can use the calendar in the regular manner and simply count ahead 20, 30 years till we get to the end of the bond. We'll do both in this video. The Bond Worksheet is also different in another respect. It doesn't have any dedicated function keys. Instead, we have to call it up with a second 9 key, and after we call it up, we look at the display and follow the instructions in the display through until we get to the end of the problem. But still, we've covered the TVM worksheet and the cash flow worksheet, and you want to know how to solve a bond with those two worksheets by now. So I think what I'll do is take two or three bond problems, and work them out 3 different ways. Once with the TVM worksheet, once with the cash flow worksheet, and once with the bond worksheet. And that way you can decide which of the methods you like best. First, however, we're going to begin in June of 1882. That's because that was the year in which the great Washington and Western Railroad was trying to sell this series of $1,000 6% 30-year coupon bonds. Now, back in the day, they made these bonds very elaborate, and as you can see, this one is, and this is 13 inches wide exactly. It's 17 inches tall. It's printed on high-quality paper that is very flexible even today, and it's printed in 4 colors. So there's a modern 1880s steam engine pictured in the top of the bond, and that's printed in black. And then there's very ornate scrolling in brown all the way around, and there's also about a 300 or 400 word prospectus of the bond written in very elaborate italic points, italic font that you can see in the middle of the bond behind the word 1000. It also has all the coupons printed in green, and then everything is overstamped in red. Every single coupon is overstamped with the number 1283. That's for every coupon and the face value. And that's because that is the exact number of that bond when they were trying to sell it. Now, making it very elaborate like that does several things. First of all, it discourages counterfeiters because it's pretty hard to do something like that that's already in 4 color. Secondly, they have a bit of a marketing edge, because if you were one of the ones that were thinking about buying the bonds and they brought it in and showed it to you, you looked at it, you thought this thing looked valuable, heck, it even felt valuable, even though it's only worth the paper it's printed on until the company sells the bond. Third, back in the day, they understood that compound interest was important. And how do you affect it? How do you get the coupon, the semi-annual interest to the investor? Well, you do it with the coupons. And you can see that we have 6 columns and 10 rows of coupons. That gives us 60 coupons. Each of the coupons is dated for a specific 6-month period in that bond's life. So if you were to buy that bond, what you would do is you would take the coupon on the extreme lower right, that'd be this one over here that I'm showing you here, and you would clip it off, and 6 months after June 1882, that would be January of 1883, you would take it into the railroad company's bank and get $30. And then 6 months later, you would take the next coupon in and get another $30. So if you have $30 twice in a year, you've got $60. That's the 6% annual bond that the bond promises to pay. That means That's going to give you a cash flow that looks a little bit like this. So you almost have a two-part problem there. You have an annuity amounting to $30 going all the way across, and then you have the $1,000 par value at the very end. And you're going to find the present value of all of these. Now, I don't know how many of these bonds the railroad company actually sold back in 1882, but I know they didn't sell this one because it's hanging on the wall in my office. Well, let's go ahead and work on a bond problem. And we'll do a $1,000 5% 30-year bond this time, and it's going to pay semi-annual interest. Well, it's a good idea always to have a little diagram showing us our cash flows so that we know what we're working with. And you can see that we have $25. That's going to be an annuity that is either carried out 60 semi-annual periods, and then you have the $1,000 at the end, or you could say you have an annuity that goes for 59 consecutive periods, and then at the end you have $1,025. That depends upon which worksheet you're working with. So you open up a finance book, and maybe you're in a finance class for experimenting or working with bond problems. And the book says, well, you have to find the present value of the coupons. Yes, you do. And you have to find the present value of the principal, add them together, and you can find the present value of the bond. But neither one of these equations are very useful because you have semi-annual compounding in the diagram, and you need to reflect that in the equation. So you look around and finally you stumble on this one where it says you can take the payment, and then you can see basically what's happened here is the interest rate has been divided by 2. And the interest rate is divided by 2, that's for half of that 6% per year. And the number of years has been doubled. And take a look at the exponent in either of these two equations, specifically this one over here or this one here. And you can see that, it's going to double it to 60 periods. So you then populate the equation. You think you have it all set up right. In fact, look at the interest rate. Now the interest rate is 0.036. That's what we want because that is half of that 0.072 in interest that we've had that we require on the bond. And all you have to do is, after you work out all the numbers, solve it, and you get 731.05. Now that turns out to be the right answer. So you'd say, good, I don't have to buy a BA2 after all, because all I have to do is use these equations and I can get through the problem. And the answer is yes, that's correct. However, somebody sitting next to you with the BA2 might do it this way. They might clear their TVM worksheet. They'll put 25 in as the payment. They'll put $1,000 in as the future value. They'll divide the interest rate by 2. They'll multiply the number of years by 2, and they'll compute the present value. And they get the exact same answer you got. Of course, they have a minus sign in their answer, but that's because that worksheet has a mathematically meaningless minus sign built into the equation, so we can simply ignore that. And I like to call that set of steps that over you see on the far right is kind of a shortcut, because that's about the quickest way you can work out a bond problem. But that's not the way the user manual will do it. And the user manual has a different solution. And I always like to show the user manual solution, so here it comes. We clear it, call it up, clear the TVM worksheet. We're going to use the same worksheet. Now we use 2 keys, the second P/Y, and look in the display of your calculator if you're going along, and you'll see the calculator saying P/Y equals, and it might say 1 or some other number. You're going to change it to 2. And of all the times we've used this equation or used this solution in the past, I've never had anything other than a 1 up in that equation. Now we have 2 payments per year, all right? And then we want to save it to the worksheet, so we hit enter, second, quit. Then I use a 3 keystroke combination, second P/Y, down arrow key. That's the 3 keys. And I call up the C/Y menu. You look in your display, your calculator says C/Y is equal to something. Well, that's for the number of compounding periods in the year. So you put 2 in for that, and you hit enter second quit to save it to the worksheet. Put 30 in for the number of years, hit the second times PY, which has a value of 2, and that'll then hit the end key. That gives you a value of 60. Put in your yield that you want, 7.2%, the $25 payment, the $1,000 future value, and you compute the present value and you get a minus 731.05. Of course, you know that that minus sign is mathematically irrelevant because we are working with the TVM worksheet, so you don't worry about that. Looks like we've got the answer again. But one thing you do have to do at this point is you have to change that P/Y register and that C/Y register back to 1. Right now they're both set at 2. And you can set both of them back to 1 with this statement. Second P/Y, second clear worksheet. And that will set both of those registers back to 1. Or you could hit second reset enter, that would do it too. But you know, if you don't do that, one of these two commands over here, if you don't do one of these two commands, your calculator is going to be set up for 2 payment periods per year and 2 compounding periods per year in every single problem that you work out in the future. And you're not going to know it because you're not going to see it. So you want to clear it now. That's one of the problems with the user manual solution, is because once you program it, you have to deprogram it and hope you don't forget it. Now what we're going to do is compare the user manual solution, which we just did, with the cash flow worksheet and the TVM shortcut. So the cash flow worksheet is the second worksheet that we introduced in this series, and it works like this. You hit the CF key to call up the cash flow worksheet, then you clear it. And you clear it with the worksheet key that's down in the left-hand corner of the calculator. That's the CE/C key. All right, I'm going to put up all the steps and I'll walk you through them. The cash flow worksheet always requires something for today. Now, assume we haven't found that 731 yet, and we're trying to find the present value of that cash flow. So we don't have anything for today, so we have to put 0. And anytime we use that worksheet, we have to put something in for today. So we put 0 in. Now we get to the next cell. The next cell has 2 component parts. The first part is for the value. The second part is for the frequency. And now we take care of the 59 period annuity. And we put 25 in, enter, save it, shift down. And then we put in 59, not 60. The reason we're not going to put 60 in is because we're going to take that last coupon and add it into that $1,000 at the end. So the frequency is going to be 59. We hit enter, scroll down. Then we get to the very next 60, the 3-month period, the 6-month period, and we put in 1,025, enter, shift down. We want the net present value, so we call it the NPV. We call it the NPV, we divide it by 2, and then we enter it and solve, and we get 731.05. And then we can use the cash flow worksheet or the TVM worksheet shortcut that we had before. That's one I like. And we put 25 in as payment, $1,000 future value, and that's where I treat the annuity different from the future value. And then I divide the interest rate by 2, and I multiply the years by 2, and I compute the answer. And both of these TVM worksheet methods give me a mathematically meaningless minus sign, so I can ignore them. So I've now worked the problem 4 different ways. I've done it with the algebra. I've done it with the cash flow worksheet. I've done it 2 different ways with the TVM worksheet. So I think I've got the right answer. Let's see if we can get the same answer if we use the Bond worksheet. Bond worksheet is very different. First thing, I'm going to work the present value of that bond. So I hit second bond, and that's the second 9 key. As soon as I hit the second 9 key, I'm going to have this settlement date right here in the display. but you want to also clear it. So you hit second bond, then second clear. Now, that settlement date is the date the bond was first sold. And you don't know when it is, but the calculator has to throw up some date there. So it puts up the date that the calculator was last revised. So yes, you have a 34-year-old calculator. Well, anyway, I wanted to pick a different 30-year period, not starting with 12/31/90. I'll pick the last day in 1990. So I overtype it with 12, that's for the 12th month period, 31, that's for the 31st day or the very last day in 1999. And then I want to enter save. So I then scroll down and I'm looking for the next instruction in the display. And I'm going to be keying off the words that you see in the display. The next thing it wants is the coupon. And I've put all of those commands in yellow squiggly brackets to indicate this is what we're looking for. So I'm going to scroll down until I get the coupon. And when I get there, I put in 5 because that's the coupon. Then I enter, scroll down again until I find the redemption date. And the redemption date is the date the bond is called in, or date the bond expires. And I'll just pick a date 30 years out in the future. So I put 12/31/30 for 2030. And now I've got a 30-year period in here. And what I'm going to do is work out the present value of the bond between those two dates. However, I've scrolled down again, and I scroll down until several times until I find the yield. And when I get to the yield, I put in the yield that I want, and we've been working with 7.2, so I'll put 7.2 in. Then I'll enter and scroll again until I get to the price. And when I get to the PRI in the display, I simply hit the compute key. PRI compute comes out to 72.8547 on the dollar. But I'm looking for the price or the present value of a 30-year bond or of a $1,000 bond. And what I do to convert that price per dollar, cents per dollar, into the bond price, multiply it by 10, and I'll have $728.55. Now, that gives me a problem because for the first time I have a different answer. 4 different times before I came up with 731.05. Now I come up with 728.55, and that's $2.50 difference. Yeah, why the difference? Well, it's due to the leap year days that are in that 30-year period. For example, there's one leap year day in 2000, one in 24, and one in 28. And what that does when you have leap year days is it takes that cash flow and pushes them out into the future just incrementally, not much, but just a little bit. And when you push those cash flows out into the future, when you discount them at 7.2%, they discount back at a slightly lower present value. So I come up with a smaller value. I get 728.55, $2.50 less than that $72.85 that I had before, or that 731.05 that I had before. Well, is that going to be much of a problem? You might think $2.50 isn't a very big deal. You've almost got the right answer. But you know, if you're dealing with bonds that are $100,000 bonds or $1 million bonds, yes, that is a big deal, and you'll want to carry your cents per dollar out a lot further than I've carried it out here. Well, now what we want to do is find the bond's yield. So again, I hit second bond, second clear worksheet, and when I do, I get a settlement date. And I want to overtype that settlement date. I'll use the same dates I had here, with the last day of 1999, which is the 12th month, 31st day of 1999. I scroll ahead until I find the coupon. When I find the coupon, I put it in. I scroll ahead until I find the redemption date, And when I find it, I type 12.3130, so I've got a 30-year span in here, and scroll around again until I get to the price. Now when I get to the price, let's assume that we got this price of 72.8547. We have to put it in on cents on the dollar. So I enter that, and then I scroll till I find yield, and when I find yield, I hit compute, and I get 7.2. So you can see how the bond worksheet is used to find a present value of the bond, that's the one on the left, or the bond yield, that's the set of commands on the right. Let's go to problem 2, and this time we're going to take a look at a $1,000 6% 30-year bond that pays semi-annual interest, and it sells for $615. We're going to do it with the bond worksheet, cash flow worksheet, and TVM worksheets. So here's our cash flow, and you can see that we have the annuity of $30 rather, because it's a 6% bond, and the present value of, or future value of $1,000. So we start with the bond worksheet, second bond, second clear worksheet. We have a settlement date. Well, let's overtype that settlement date with our last day of 1999. Enter. Scroll down until we find the coupon. Coupon is 6. Scroll down until we find the redemption date, 12.3130. I'm 30 years out into the future. Scroll around several times again until I find the price. Now, the price of this bond is $615 out in the market, and we want to put that price in cents in the dollar, or cents on the dollar. So what we do is we divide the 615 by 10, and we have 61.5 cents on the dollar. That's our price. We scroll down again until we find the yield, and we compute it. We come up with 10.07. Now, we go to the cash flow worksheet. Call it up. Clear it. We put $615 in today because we know the price of the bond today. And we put it in as a minus sign because it's an expense. That's what's going to cost us. Enter, shift down. We get to the next cell, and the next cell has room for two values. The first, the 30, is for the payment itself, and the 59 is for the frequency. So we put 30, enter, shift, then we put 59, enter, shift, and then we go to the next one, and we put in the 10,030. That's the future value. We have to, when we do the cash flow worksheet, we really have to add that last coupon to the par value of the bond. Well, then we ask for the internal rate of return, hit compute, and we come up with 5.05. So the yield that we found, or the internal rate of return that we have found on this bond, is only 5.5%. But don't forget, we have found it for a 60 period problem. So this is half a year. All we have to do is double it to 10.10%, and now we have the bond's yield if we do the cash flow worksheet. If we do the shortcut method that I like best, second, clear it, put 615 in as the negative number, 30 in as your payment. Now this time we treat the annuity completely separate from the future value, so that we have a 30-period annuity rather than a 59-period annuity. That's the difference between the cash flow worksheet and the TVM worksheet. $1,000 future value, 30 times 2, because we have 60 periods, and we compute the interest rate, or the yield, and it comes out to 5.05. Well, again, we have computed it for a 6-month period. So we just double it, and we get 10.10%. And now we see that the bond worksheet is going to give us a lower yield at 10.07% than either the cash flow or the TVM worksheets, which give us a 10.10%. Well, that's to be expected, because don't forget, if we take those cash flows and put them out further into the future, the present value is going to be less, well, then the yield is going to be less. So we would expect the yield to be less on the bond worksheet. That takes us to the end of everything I can say about the bond problem. And for a final recap, just remember that you can solve any bond problem with the TVM worksheet. Why? Well, because you can combine that annuity with the future value and work out the present value that way. Just remember that you're going to have a mathematically meaningless minus sign that you have to ignore. Bond problems can also be worked out with the cash flow worksheet. Now, the cash flow worksheet works because cash flow worksheet is designed for uneven future sums. So you're okay there. And you also are working with 60 or 30-day generic months when you use the cash flow worksheet. Most bond problems can be solved with the bond worksheet. Well, why? Well, the bond worksheet allows us to give a lot more precision. We can take the bond settlement date and take it through to its redemption date, or we can use calendar months. And when we use calendar months, just remember, we're going to have some leap year days that are going to reduce the yield modestly and reduce the present values just modestly. Other than that, we have 3 different worksheets, all of which are called up and cleared differently, all of which are going to be useful to you in the future, and I hope that you get the best out of this TI calculator. It is a powerful little device and it will serve you well.